Let's take a look at investigation 3, systems of functions, and now we're going to be taking a look at these things called inequalities. We've looked at them before. Those were when we had the inequality signs greater than or less than, greater than or equal to, less than or equal to. Those are inequalities. There may also be the not equal to one, but they're not commonly put into this category, even though the not equal to is technically an inequality as well. Just know that it might show up. So in this problem, we have two different companies that we're looking at. We have Superlocks, which has a $3,975 installation, $6 per day for monitoring, and then you have Failsafe that is only a $995 installation fee, and then they are $17.95 per day for monitoring. So we're going to try to choose between the two of these companies. We're going to ask different questions. We're going to answer different questions about them. And these are some of the questions that we're going to look at. We're looking at, can we come up with linear functions? What patterns do we see? And can we use graphs to answer questions about them? So the first thing I want us to do is go ahead and copy this information into your notes about the two different companies that we have. So just like this, we have the information in our notes, the pertinent information. You don't need to copy everything down, just what you really need to start answering the questions. And so if we look, they also give us a map. So let's take, not a map, but a graph. Let's take a look at that graph. And you notice that there's a red and a blue one. And so I highlighted these two companies. The Superlocks is the red one. So let's go ahead and label that. This is Superlocks. And we know that because remember the install fee, that's the initial cost, was almost $4,000. And then the other one, the blue one, that is your failsafe. So we're going to go ahead and label that. So in your notes, just make note that the blue line here is failsafe and the red line here is Superlocks. And also here the dependent axis is your cost in dollars. Your independent is the number of days that you're purchasing these services. So let's take a look at part A. We're using the graph to estimate the answers to these questions. Go ahead and answer all of part A and then come back to the video. So this should take about 2 to 3 minutes. So pause it and then come back to the video. The first question asks, what number of days will the cost of the two companies be the same? So right here is where they are the same. So right at that point right there is where they cross. So it asks how many days. So if we kind of look in, put a point right here, and then go straight over, it looks about 5,500 days. Oh, nope, sorry, that's the cost. I was looking at, if we go straight down, that's about 200, and my dog's escaping, 250 days. Because the second part then says, what about the cost? So we have that right here. The cost is 5,500, and the number of days is 250 days. So number 2 says, for what number of days will Superlocks cost less than Failsafe? So remember, Superlocks is the red one. And so if we highlight where the red one is less, where it costs, nope, that's the wrong one. There we go. Where it costs less, that means it's below that blue line. That would be right there. And so the number of days, for what numbers of days? It's when the number of days, let's do this in red. So this is A2. And it has to be greater than 250. Okay, so the number of days has to be greater than 250. And then on part 3, It says, for what numbers of days will fail-safe cost less? So now we're looking at fail-safe, and it's going to cost less right here. So I'm highlighting in dark blue. And this is a 3. Fail-safe will cost less when the number of days is less than 250. All right, so there's when the one is going to cost less than the other. Now let's take a look at question B. Question B, you're basically coming up with those equations. So for each company, write an equation, and they tell you even what variables to use. C for the cost, D for the number of days, and then write an equation for an inequality that you can use to answer each question. So go ahead, remember that inequalities have the greater than, less than, or equal to signs. So go ahead and try B parts 1 and 2 on your own, and then come back to the video to see how you did. So let's go ahead and answer these. So for each company, so let's take a look at the red one, which was Superlocks, and the blue one was Failsafe. So let's try answering these questions. Let's come up with the equation for the red one there. So this is B1. The cost is equal to, remember the initial value, that starting value is our y-intercept. So if we're doing y equals mx plus b, that's our plus b portion. And that was 3,975. Then our plus the mx, that's the slope. So remember, this is $6 per day. So it's going to look like this. You could also have 6D plus 3,975. So either one of those would work. And then if we take a look at failsafe, that has a slope of $17.95 per day, with an initial fee of, all the way down here, $995. So at day 0, it's $995. Okay, so there we have our two equations. So those are the two that we're going to go ahead and use. And that's part 1. Part 2 says, write an equation or inequality that you can use to answer each question. So we're going back up and answering for what number of days does the cost of the two companies be the same. So we're going to go ahead and answer that by just setting them equal to each other. So we're going to set 6D plus 3,975 equal to $17.95 per day plus 995. So that's the first part that we do there for part 1. If you haven't done this already, go ahead and pause the video and solve this on your own to see what you get. Okay, so let's go ahead and go through and solve this. First thing I'm going to do is subtract 6D from each side, and then what we have left is $11.95D plus 995 is equal to 3,000. So you can see it, and then I'm going to get the 995 onto the other side, and then I have this, and divide out that 1195 and the number of days. And we said earlier, looking at the graph, it was 250, but the exact number of days is 249 days, 0.37 of a day. Okay, so about a quarter of a day, a little bit more. And then the next two are looking at what number of days will Superlocks cost less. So let's take a look at that one. We're going to go ahead and set this so that it's the Superlocks. The cost of the Superlocks, 3,975, is less than 17.95D plus 995. And you notice this is the exact same thing that we did. So when we go through and solve this, just like what we did, we ended up with D was equal to, D was on the right side, so this is going to be D is greater than the 249.37. Like that. Let me erase this in here. And then the second one is it's the other way around. We're setting, hey, when is the fail-safe going to be less? So it's just flipped around. So it's 1795 times D. And we want to know when that's going to be less than the cost of the other one. But again, we've already done all of this, and we ended up with D. This time, D is going to end up on this side when we go through and solve. So it'll be D is less than 249.37. Which, looking at the graph, remember we got D is greater than 250 and D is less than 250 for those same two answers. But this gives us exact decimal value answers here. Now let's try this with different equations, different inequalities to kind of get a sense of what that looks like. So let's start off by graphing equations. So let's look at number 1. You'll need some graph paper here, or if you are really good at drawing grid on your coordinate planes, that's fine too. But go ahead and graph these. So there are two different equations here. You have 2x plus 1, and then your other one is 1/2 x plus 4. Go ahead and graph those on the same coordinate plane, and then come back to the video to see how we did. Now remember, you're solving. That means you're finding where they cross, that point where they cross. So go ahead and graph them, solve them, and then come back to the video to check your answer. So if we look at the graphs here, we have the two equations, 2x plus 1 and 1/2 x plus 4. So I pulled out the slope and y-intercepts. So let's go ahead and graph the first one, this 2x plus 1. We start with the y-intercept of 1, so it's crossing right here, and then a slope of 2. That means I go up 2 over 1, up 2 over 1, or down 2 to the left 1, down 2 to the left 1. So here is my graph of that first one. And I'll highlight that so we can see which one that was. And then if we take a look at the second one, we'll do this in green there. My y-intercept is 4, 1, 2, 3, 4. And it has the slope of 1 over 2. So that means I go up 1 over 2. And I can see that that's where they're going to cross right there. Let's erase this. Up 1 over 2, or down 1 over 2, down 1 over 2, down 1 over 2. And so here is my graph for that second one. See if I can get a little straighter. Right there. And you can see where they cross. If I bring this one out a little bit more, right there is where they cross, right? So that's our solution. And that is at the point, it looks like 2, 5. So x is equal to 2, y is equal to 5, and that is where they cross. So that would be the solution of those two equations. Now we can look at the graphs and find that, but we can also use different methods to solve them, which we've been doing before. Right? They're both solved for y, and so we can just set them equal to each other. So 2x plus 1, let's put this back to black. So 2x plus 1 is equal to 1/2 x or 0.5x, it doesn't matter. So write this down in your notes and go through and solve it, and let's see what happens. So when you go through and solve this, you subtract the 1/2 x from each side, and then subtract 1 from each side, and you get 1.5 x is equal to 3. You get x is equal to 2. Well, look at this. X is equal to 2. So to find y, you would just plug it into one of these. So I'm going to choose this one. We had y is equal to 1/2 times 2 plus 4. So y is equal to 1 plus 4. Y is equal to 5. So we got the same answers, x equals 2, y equals 5. We were able to graph it and get that exact same thing. right? So graphing is good because you can visually see the relationship, but checking them on an equation is good as well. Now the question is, what about these inequalities? What does this do to our solutions or equations? Because you look at 2 and 3, they're the same functions on each side, just the difference is that equality between them. Here we had an equal sign, now we have a less than, then a greater than. So the question is, what does that do? How does that change things? Well, let's go back to our graphs to answer that question. So right now, if we look at this, I'm going to rewrite that inequality in part 2. It was 2x plus 1 is less than the 0.5x plus 4. So you're trying to answer this question. And I try to remain consistent with these colors that I'm using. It's asking, hey, when is this yellow graph less than this green graph? Well, if we look over here, the yellow graph is less than the green graph right here. All right here, because right here it's above, so it's not less than, so it's only right here. Okay? So then we have to describe where that happens. Well, you can go through and solve this inequality, but if you remember what we got x equals 2 down here when we went through and solved it, so we're going to get the same thing. It's wherever x, your x value is less than 2 is where it's going to be smaller than, right? So the answer to this is going to be x is less than 2. So this is the question, the answer to question C2 right here. Okay, the yellow graph, the 2x plus 1, is less than the green graph, the 1/2 x plus 4, everywhere when x is less than 2. Okay, and again, you can set it up like this, go through and solve it. You'll get the exact same thing, but graphically you need to be able to see what does that look like in terms of the relationship between the green graph and the yellow graph here. So now, if we take a look at the next one, part 3, it's the same thing, only the inequality is flipped. When is this greater than the 0.5x plus 4? And that's going to be on the other side. So it is greater than up here. So let me extend that yellow portion because that graph continues. So it's greater than up here. And so if you were to go through and solve this, you would end up with x is greater than 2. Right? You subtract 1 from each side, and then you subtract 0.5x, just like what we did down here, doing the exact same thing, solving for x. You would get x is greater than 2. So the question is asking, when is the 2x plus 1 graph larger or higher on the coordinate plane than the 1/2 x plus 4? And the answer to that is when x is greater than 2. Okay, so in your notes, I want you to go ahead and try 4, 5, and 6. So C, 4, 5, and 6, you notice they're all the same functions on each side, just one has an equal, the other has a greater than, the other has a less than. So go ahead and try 4, 5, and 6, and then come back to the video to check your answers. So here we have our two graphs. And I have all the equations there at the right, and you notice that your graphs cross right here. So at that point, which is 1, 2, 3, x equals 4, y equals 2. So x equals 4, y equals 2 is your solution. So over here, they cross at x equals 4. And again, you can go through and solve that if you wanted to go through and solve that. We'll just do that real quick right here. We would add 2 to both sides, and also we're going to add an x so that it gets rid of those. So you would have 2x is equal to 8. Divide each side by 2, you get x is equal to 4. Which, does that match over here? Yeah. So x is equal to 4. And then on 5 and 6, so on 5, it's asking when is the red graph less than the green graph, and the red graph is less than the green graph right here. So it's where everywhere x is less than 4. So it's everywhere x is less than 4. And then the opposite says, hey, where is the red graph greater than the green graph? That would be on the other side, everywhere x is greater than 4. So those would be your answers, your two answers there. And again, like for this one, if we didn't have the graph, we could go through and solve it just like before. Plus 2. Plus 2 plus x. That gets rid of those there. That gets rid of those there. And then you would have 2x is greater than, because you just carry that down, 8. And then divide by 2, you get x is greater than 4. Just like what we see on our graph, the red graph is bigger than or higher than the green graph when it's to the right of x equals 4. So now go ahead and do 7, 8, and 9 in the same fashion. Okay, so when we go through and graph these, again, we'll have the two different functions as two different colors here. But for the red function, our y-intercept is 4. So we know that we're going to have to go all the way up to y equals 13. So I'm going to go by 2's. So this will be 2, 4, and so forth. So y equals 4 is right here, and this will also be 2, just to keep it. So y equals 4, and then your slope is 3. So then to 3, so you go up 3 over 1, up 3 over 1, up 3 over 1, and you can keep going. And it's going to look something like this. So that's the red one, so I'm going to highlight that in red. Now with the green one, it's just y equals 13, so it's just a horizontal line. 4, 6, 8, 10, 12. So right here, 6, 8, 10, 12, so 13 is right here. It's just going to be a horizontal line right there, and we're going to go ahead and color that one so we can see that that's the green one. And we can see right here is where they cross at that point there, and if we look, that point is x equals 3 and y equals 13. Okay, so x equals 3, y equals 13. That's where they cross. And again, if we go through and solve this equation, you would get x is equal to 3. Because when you subtract 4 from each side, right here, when you subtract 4 from each side, you get 9 is equal to 3x. So 3 times what number equals 9 has to be 3. Okay, so it's all working out. It's all proving that the graph, that we graphed it correctly. So when you go through here, the first one is saying when is 3x plus 4 less than the green line, and that's going to happen right here. Whenever x is less than or equal to, this says or equal to, meaning it can be that point. So it's where x is less than or equal to 13. Sorry, not 13. That's y. X is 3. And where it's greater, that's going to be on this other side right here. That would be x is greater than or equal to 3. So now let's take a look at this in the context, because part D asks about what do these look like on a number line if we were to graph those and how they're related to this. So first of all, if we graph, it's going to be kind of hard. I'll just do this. If we graph x equals 3, like up here, on a number line. Remember, a number line is just your x-axis. Okay, x equals 3. That means the only answer that will work is 3 itself. So that is your answer right there. And in an equation where they cross, they can only cross at one point. So you have a singular solution, right? And I know we're not including y here because y is the value. X determines the place it happens, right? So it happens at x equals 3 when y is equal to 13. But when we're graphing, we're only using the x-axis here because we only have one variable. So if we're looking when x is less than 3, this less than sign means it's an open circle at 3. But the inequality states what values are less than 3. That's all of the values smaller or on a number line to the left of 3. So our graph would look like this. And so if it was x is less than or equal to 3, it would look very much the same. The only difference is it can be 3 and all of those values to the left of 3. Now, if it was x is greater than 3, like this one here, this was greater than or equal to 3, and it was all the values to the right of 3. So if it's just greater than 3, it's an open circle, and you're shading to the right there. But if it was x is greater than or equal to 3, it would be a closed circle because it can be 3 and it's shaded to the right. So if we look, for example, let's look at this one right here. When x is greater than or equal to 3, it's saying all the values to the right of 3. So that includes 4, 5, 6, 7. And if we look up here on part 9, it's asking when is the red graph larger than the green graph? Well, the red graph is larger than the green graph or higher than the green graph at 5, x equals 5, 6, 7, 8. So all of these values of x that are to the right of 3. So here we have graphs of all of our possible solutions, right? So on that last one, any value greater than or equal to 3 are going to work because all of those values of x are above that green line. So that's the relationship between these inequalities and graphing all of the possible solutions using inequalities. So whenever there's one variable, you only use one axis, and here we're using the x-axis, as opposed to when we have two variables, we throw in that y-axis right here. So then that takes us to the very last one. We already answered part 1 on D, but if you look at part 2, we're graphing these. And so I have the solutions that we already got we did this on the first, what was it, 1, 2, and 3, I think. But anyway, we have these already. So quickly just graph these inequalities right here on a number line. It should take about 30 seconds or so if you're kind of smelling what I'm stepping in here. So try these and come back to the video. Okay, so for the first one, this is showing all of the possible solutions, and there's only one solution. The second one is saying whenever x is greater than 2, those solutions will work. So it's an open circle pointed to the right, and this one is greater than or equal to. So it's all of the values to the right as well as to itself is a possible solution, meaning if I plugged 7 in here, so 2 times 7 plus 1, that should still be greater than or equal to, in this case it's going to be greater than the other side. But if I plugged in any value less than 2, like if I plugged in 1 here, right, so erase that 7, And if I plugged in 1, then this would not be true. The right side would actually be bigger than the left side. And that is it for 3.1, comparing security services.